Hello my favorite people. Welcome back to our channel. Let's continue with our episode. In the previous episode, we have checked how we can integrate our repository while we're going to create the order. Right? So we have reviewed the a complete pipeline from the routes to service to repository. So now our pipeline is clear. Like we can create the order by hitting our endpoints, right? And we have integrated the to check the user authentication as well as, right? So while we are going to visit our order service to make sure that particular user can have the accessibility of his own orders only, right? So now this episode, today we are going to work on our purely Kafka. So if we can see in the source code here in the Express app, you can see we have a couple of codes. It is laying down right here. That is, we have added in our one of the previous episode where we have onboarded the Kafka to our microservices. And if you have not watched that particular episode, I would highly recommend it. Let's go ahead here in the description below, right? I have already posted the link of that particular episode and check that episode out, right? So right before jumping to this episode, because this episode will be going to be a little bit more advanced than the previous one. So let's have a look what we have here, right? So if you see here inside this broker directory, we have one file that is called API, right? So API is being used for synchronous communication. So I have already explained what is synchronous and asynchronous communication in one of our previous episodes. But this episode, we are not going to discuss all those things, all right? Rather than stressing the whole episodes a little bit longer, so I don't want to do that. So maybe I'm gonna record another episode based on like the communication pattern, like maybe how asynchronous and synchronous communication works and why exactly it's needed, and what is the event-driven architecture or how event sourcing is working, right? So all those things maybe I can explain in that separate video, right? So let's focus on the this particular episode specifically for Kafka. So right now you can see this API is being used for synchronous communication, and asynchronous communication we are using the Kafka, right? So where we have created one type that is called message broker type, right? So why this message broker type is it's needed, I have already explained in the onboarding video of the Kafka, right? So maybe you can watch the same. And here the message broker type is exactly, we are just to try to make it generic. So every time while we are going to implement some different type of message broker, let's say today we are going to use the Kafka here, and maybe tomorrow we have decided not to go with the Kafka. Maybe let's go with the AWS SQS, maybe RabbitMQ, or maybe Redis or something like that, right? So maybe that's a different story, right? So we can do that. But to implement those possibility, we need to keep our provision right here, right? So every time you cannot accommodate the tag depth. So why I'm saying tag depth? Because if you are not keeping these provisions today, then maybe while your application will go live on the production, then at the time when there are certain requirements, it will come to our application. Then let's say we need to accommodate that particular tools or library. Then again, we need to change all this stuff. So to get rid of this kind of situation, we are just to try to make it generic. Like we have introduced one type that is already been implemented in the message broker.ts file. You can see this is the file where we have added all the Kafka related codes. So tomorrow, let's say if we need to integrate, let's say RabbitMQ, then definitely only we need to change this file. Then rest of all the mechanism is gonna work because it's complying this message broker type, right? So where maybe connect producer, disconnect producer, publisher, or maybe connect, disconnect, subscribe, whatever, right? And we have certain types also we have used for publishing the messages, right? So those are the things that will be remain same, right? It's not going to be like change at all. It will stay unchanged. Now let's move forward with our code. So right now you can see our Express app is growing bigger, right? So as soon as, because see right now we are trying to powering this event or maybe subscribing this one. Maybe tomorrow some more events will come. Then this file will grow big, right? So then growing this file is growing big. That's not a problem at all. Maybe we can accommodate. Maybe we can split these things to a separate function and we can utilize inside the Express app. The real problem will be occur when you will try to run your test, right? When you will you will try to test your components. That is the problem, right? So that's why what we need to do, we need to follow some kind of like singular responsibility. So we need to delegate this responsibility to particular class, particular service, or particular function, all right? So at least it can be testable or it can be maintainable, right? At any point of time, if you want to change this this listener, all right, or maybe you want to change the producer code, then you no need to come here, right, in the Express app. So you can maybe change right there on that particular dedicated class or function or something, right? And it should have to work as it is, right? So let's try to do that way. So what I'm gonna do, I'm gonna comment it out all these codes from here, right? So this is not required right now. And here inside this broker, let's have a look what we have here and how we have implemented all this stuff. So inside the message broker, we can see like we have our client ID, group ID, all these things, right? So definitely we are going to get rid of all these things from here shortly. While we're going to prepare these things to deployment, then these things are not required, because if we are not providing the environment variable, then our application should not supposed to start at all, right? So because those are really dangerous to providing the hard-coded stuff right there. But this is we kept just for sake of, in terms of like to kickstart our application smoothly. That's what we did. So secondly, here we are just creating our Kafka instance. You can see we are providing our client ID, right? And we are providing our brokers in multiple array. So why it's a kind of array? Already I have explained in that video. So go ahead and check it out, like why this broker is needed kind of array. And a log level is fine. So we are just like try to find it out the log level. So while our Kafka are going to start, then at least we can receive some kind of logs of each and every activity, right? So that is really helpful while you are going to push these logs to the metrics. So at least you can observe your application health, or you can observe like each and every activity of your message brokers are doing behind the scene. Right. So now you can see we have just created some global producer and consumer. So those are extremely necessary, because why? Every time you are just connecting to the consumer, connecting to the producer, if you're not keeping outside of the instance, then definitely it'll going to open a new connection every time you are trying to connect, right? So that is what we don't want, right? So every time we are going to connect or maybe restart your application, restart the application is perfectly fine. But while we are going to connect the application or maybe call the application, so it should supposed to check like if we have a producer already exists. If it is already exist, why we need another connection? Let's try to reuse that. So that mechanism, it is going to take place from here, right? And you can see the create topic. A lot of people, they're creating the topic with the help of some kind of like maybe CLI or something. That's really cool, right? But that is only applicable in development server, all right? So you cannot create these topics, all right? All these topics or all these like, channels, like in another language, you can say for some other message brokers. So all these topics and channels, you cannot create on the production server by going to the CLI. That's a kind of really overwork, right? It's a manual work. So we don't want to do that. Why? Because you don't know like what is the exact time your code will be deployed. Because let's assume you have 4 people are working in the same project. They are working in some different functionality. While they are going to submit, they're going to merge your code, all right? They're going to deploy the code, all right? You don't have any control at all, right? So these things has to be automated, right? So these things, while your application going to start for the first time, then it has to take the responsibility of the creating topics, existing or amending topics, whatever. It has to be automatic. So that's why we said like create the topic, right? So it will going to check like if the proposed topic is already created, already exists, do nothing, right? And if it doesn't exist at all, then just create the topic, right? So that's why we're just creating all these things from here. Then finally disconnect. Why it is disconnect? Because once the topic has been created successfully, then disconnect it. That's all. Then finally, because can you see like this is a kind of admin, right? So because admin only has the capability of the create the topic, not per normal brokers, right? So that's why we said like admin connect, admin do perform the whatever the admin operations right there. Then you can do the stuff and then just go ahead and disconnect it. Finally, we are connecting to the producer and the consumers, right? And connecting to the producers and the consumers are happening in 2 different stages. In terms of like our application, if you see in this diagram, right? And while our order service is going to be start, at that time you can see order service not only having the responsibility of listening, right? It has the responsibility of firing some events as well as, right? So right now what is happening here, you can see the order service is receiving the, I have not added all these connections because it was a kind of different diagram, right, where we discussed like only the flow of the order, but still we can connect all these dots right there. If you can see here, once the order service will receive the order, all right, receive the events. As an example, the cart service is moving forward, and it is creating the order right after receive the payment. Then what it will do? Order service, as soon as order service will receive the order, then it will notify to the catalog service, right? So let me pull like this way. So it's going to intersect here. Yeah, cool. So let's try to make it kind of like this, because it's a kind of weak connection. I'm saying dash means weak connection, right? So, and let's try to make a different color so at least it can be identical. Yeah. So right now you can see our order service, as soon as it is receiving the order, and then this request call. This is a kind of Kafka call with stock deduction, right, for product IDs, right? So yeah, so you can see, so once we received the order in the order service, then definitely we need to tell to the catalog service, gonna say, hey, please like deduct all these products from the stock. Otherwise, again, customer will come to here to browsing the product, then they will see like, oh wow, the products are available, right now Black Friday sales are going on, or whatever the sales or promotions are going on, let's try to buy all these products. But you can imagine, if you are not deducting all these things from the product, like from the catalog, right, then customer will end up with the the unfulfillment orders, right? So those orders are never going to be fulfilled because those products are out of stock. So we forgot to fire this event from order service to notify to the catalog service, gonna deduct these stocks. So this is the responsibility as a kind of, you can say right now it is a kind of publisher. You can see the arrow, it is coming from order service to catalog service. It's a kind of publisher. And same applies, right? Same applies. So while customer will be make the payment, all right, then we need to change the order status as well as, right? So it's a kind of, I'm not saying we need to change the status right away. Maybe we can change the status in later stage also, right? So it depends on what kind of mechanism we are going to follow. As I explained, there are two types of order mechanism we can apply. So both the mechanism can have a different scenarios, right? So I don't want to make it too complicated. So let's try to make it a little bit easy maybe. So right now you can see order service is publishing that particular deduct event, and this order service also need to receive the event from where? From order service. As an example, right now the order service is received the event from the payment service, as an example this one, all right? So let's try to make it again the same, because those are a little bit I don't know, it's a kind of purple color maybe, or maybe dark blue, whatever. So this type of colors are you can assume those are Kafka calls, all right? And right now payment service is powering this call. Let's gonna say cancel order. And this time what is happening? This time maybe you can fairly understand, like this time the cancel order is happening, right? And cancel order is a kind of consumer right now. Right now, same service is acting as a kind of consumer as well as listening to what? Listening to cancel order. And if the cancel order is happening, then what it's need to do? Then it's need to fire another event to catalog service. Gonna say, hey, it's my bad. I said deduct these 10 items from the stock. Right now, we have received a kind of cancel order events from payment service. Unfortunately, we have not received the payment or payment denied or whatever. Right now, please, again, increase the amount of that particular orders, right? Particular order, all these product IDs. So 10 product IDs should not supposed to deduct again. So in the first call, this call, let's say as an example, right now, the stock was, let's say 100, all right? And then we said deduct to 90, right? Deduct to 10, it's going to be 90 again. Then we have received the cancel order. Then we are saying please don't deduct to 10, all right? Maybe increase this product ID because we have canceled this order, right? So again, this product stock will become 100. So that mechanism, it has to be tackle internally, right, without any user's intervention. So that is what we are going to achieve with the help of the order service and catalog service and payment service. So that's why what we need to do, we need to keep this provision of order service per publishing this event as well as and listening this event as well as. I know it is a kind of really boring lecture maybe, but still you guys need to understand like what we are trying to do and what we are trying to understand, what we are trying to achieve right here. Cool. All right, so no more diagrams, no more lecture at all. So let's try to close this one. Let's go back here. And right now you can see that's why we have this producer call and we have our consumer call also, right? But you can see this file, this message broker file is too generic, right? So here all the functions are scattered in terms of like you need to connect to the consumer, disconnect to the consumer, you need to subscribe, you need to publish. So all these things we are exporting. And if we are going to implement all these things in the Express app here, this is really going to be a massive one, right? This is not going to be anymore like what is called singular responsibility. It's going to handle like everything together. Is a massive Express app is handling everything. So we don't want to do that. So what we are going to do, let's try to remove all this like unimplemented stuff from here. And if you see here inside the service, we have a couple of services in terms of one of the cart service and another one is the order service. The similar way, the cart service is responsible for all the cart operation and order service is responsible for all the order operations. And as we follow like all the singular principles, so that definitely like we need to introduce another service which is specifically going to handle all the use cases of the message broker, right? So let's try to create one broker service here, right? This is going to be broker service. TS, right? So inside the broker service, so what are the things we are going to add it here? So let's try to list it out first. Let's say first of all, initialize the broker, all right? Initialize the broker, right? Then what we need to do? Then we need to keep listening to consumer events, right? Then what we need to do? Then we need to perform like once we are receiving any event, then perform action based on the events, right? This is the things we need to do. And the third one, what you need to do? These are only for consumer. Then the publisher part, all right? The publish dedicated events based on use case, right? Based on use cases, right? It's a plural. All right, so now we have our broker service. So let's try to add some code together to complete this broker service. Here, first of all, we are going to say const initialize broker. All right, this is going to be a async function, that's for sure. And first, what we need to do, we need to create our producer, right? Const. All right, as I said, our order service will be producer and the consumer will be bot, right? So producer will be await. Then we can say broker or message broker. Message broker, right? Message broker, and this message broker exactly we need to import from our utility, right? So here, so let's try to message broker, right? Message broker. Then we are going to say connect producer, right? And you can see we can directly connect to the producer. That's fine, but if we are not going to provide the type, you can see here the connect producer is accepting some kind of like type as well as, right? So if we're not providing the type, then we cannot get the code sense from here, all right? So let's try to provide the type as well as. Here we are going to say type will be our producer from Kafka.js. And once the producer is connected, let's try to print some kind of logs also, so we can determine whether our producer is properly connected or not. Producer on, right? On connected, right? On connect. Then we can say some kind of successful log message, console log, producer connected successfully. Cool. So our producer is connected. So now let's go ahead and create our consumer as well. So consumer will be await again, message broker, connect consumer. Here also we need to provide the type. In this way, we can get the code sense, right? And we can get the benefit of like all the available functions of our Kafka.js, right? For consumer or producer. So let's try to provide a consumer. All right, consumer, and consumer is updated right here, right? And in the similar way, we are going to notify to our application is gonna say like, hey, it's connected, consumer is connected successfully. So now our producer and consumers are ready, but producer can fire some kind of event, or I maybe publish some message, and consumer can consume the messages. All right, so our producer and consumers are ready, right? So producer can produce our messages and consumer can consume the messages. But consumer cannot consume the messages unless it is subscribing to something. So let's try to complete that particular part as well as. So in this case, await, we're gonna say message broker, subscribe. Subscribe to what? Subscribe to something, right? So first of all, in the first parameter, if you go to subscribe, and you can see first parameter is a kind of handler. Handler can be a kind of anonymous function, all right? So we are going to say anonymous function. And second parameter will be our topic, right? So which topic we are going to subscribe? We are just going to say like all the order events, right? And now you can see we are fairly subscribing, but we need to handle the event, right? If you go to the subscriber function right here inside this message broker, in the subscribe function, the first parameter is a kind of handler. And handler is a kind of signature that is called input type has to be message type, right? And it can be void or anything, but this signature has to match while we're passing any kind of functions to subscribe, right? So right now, let's go ahead here in the broker service. Let's try to hook up something here that is already we have created in our previous lecture. Let's go to our order service, and you can see this handle subscription. But handle subscription signature doesn't match with our broker service this signature, right? So the subscribe function, the message handler signature. So let's try to match it first. So in this case, message as an example, message is going to say message type, message type, right? So now message type is this signature purely going to match. It doesn't matter like what type of name you are keeping for this variable, right? But this type, the data type has to be matched, right? Now let's implement this one. This is going to be say handle subscription from the order service. You can see this one is imported from our order service, and it is not complaining. It's not complaining anymore, right? So we can fairly hand it over this once any kind of messages are coming to the consumer by this particular topic, all right? By this particular topic event, then our handle subscription functions can tackle everything, all these things. So it can perform like maybe delete order, get order by ID or whatever, right? So whatever it is asking from that particular message, then it can be performed accordingly. You might have a question right now because you may be thinking like, hey Jay, we have the consumer here, but why we are using message broker to subscribe this one, right? You can imagine here why we have created this subscribe. If you go to the message broker here, you can see this subscribe function, right? This subscribe function has a lot of things to do. So first of all, it is like consumer is getting the consumer, then again subscribing to that topic that is already we did, all right? And we need to write all this logic right there, right? Here, if we are going to listen to that particular thing here you need to define all the logic. And additionally, what we need to do, we need to hook up with our handler, and we need to notify to our queue as well as they're gonna say like, hey, we have already received this particular message. Now you can just delete that one, right? So all this complexity, we are just like moving aside to the subscribe function rather than like creating here. That's why we are just using this message broker subscribe rather than directly use here, right? Because this is a kind of, as I said, it's a kind of singular responsibility, right? So we are just like initializing this stuff here. It has to be initialized, not do beyond that, right? So this is also, it's a part of like initialization where we are just like handing over to subscribe, right? We're initializing the subscribe function right there. We're gonna say, hey, this is our handler and this is the event you are going to receive, right? If you're gonna say, hey, order event, then you just need to raise your hand. You just consume the message, do whatever do. That's your responsibility. Our initialize broker function responsibility is only to initialize the producer, only to initialize the consumer, only to initialize this like particular event and hand it over to this one. So this is the way we are going to do initialize. So right now, let's go ahead and This part also we did here, right? So keep listen and perform the action based on event. This is also going to be like inside here, right? So now what we need to do, we need to create a couple of events, couple of like functions, more functions, just to dedicate it to the way we did for our initialize, and similar way we need to do the publish. And maybe we can use the publish function here as well. As you can see, like in the message broker, we have one publish function, right? This one. But you can see this is too generic, right? So every time you are going to publish something, then you need to call this publish function, and you need to define all these things. Like, you know, let's say as an example in the order service, if you need to publish the create order, right? Then you need to add the logic right here. And you can imagine, let's say in another place also you need to do the similar mechanism for the creating order, not only from here. You need to trigger from somewhere else also. As an example, the admin can create the order, let's say without notifying the user gonna say, hey, I have just lost this order, and then I don't know where to go. Then admin created the order, then it will not fall into this one, right? So it will be called from somewhere else. So by keeping this kind of usability, that's why we are just like, you know, introducing this broker service. It can have a dedicated functionality to create that particular order for us, rather than repeatedly writing the same logic over and over. So let's try to create a couple of more functions. This is going to be like export const send order message, order create send create order, right? Create order message. All right, so here inside, let's try to add some code quickly. This is going to be say await, right? Message broker dot publish, and inside the publish we are going to create on one object. The first thing will be like our event, all right? And event will be what? Event will be our order event, then order create order, right? Then second one, we can say topic. Why? What kind of topic we are going to send it here, right? To whom exactly we are going to send this topic, right? Send this particular message. So in that case, we're going to say catalog event, all right? So because our order service is only going to listen to the order events, then catalog service is going to listen to what? Catalog events. That's why we are sending the topic right here to catalog events. Now let's go ahead here and we are going to say headers. Let's say we are not putting any headers as of now. Maybe we can pass some kind of authentication header. That is also we're going to visit shortly. Then finally messages, right? So messages, we can put any kind of data that is we are sending right here, right? So now you can see this send create order message. It doesn't matter like where we are creating this the order, but at any place you are try to publish this message, you just simply need to call this send create order message from the broker service, right? So you don't need to write the repeated logic right there. And similar way, let's try to create one more function, right? As of now, I can see there are two possibilities maybe we can have right here. Const, this is going to be like send order cancel order cancelled, right? Cancelled message. And this way also it's going to be same, all right? In this case, like await, all right? Await message broker publish. And what we're going to publish here, we're going to say like event will be the order cancel, right? Order event cancelled. And after that, we can say topic will be catalog event, and headers will be empty, and data will be there, right? So now you can see there are two dedicated functions we have just created from the message broker service. At any point of time, well, we're going to cancel the order, just like prior this one, all right? Otherwise, you can just create this one, and you can add as many as whatever the possible events you need for our Kafka operation, right? Cool. So now this part is completely done, right? So now let's go ahead here in the order service. Maybe we can handle this order service event for a while, but let's try to console this log. Console log message received by order client, order consumer, let's say order Kafka consumer, right? So what message we are receiving, that is I'm just trying to printing out. And message broker is all right. Let's try to close this one and this one as well as go to broker service. This is also pretty cool, right? So this initialize broker, maybe we have not exported. So let's try to export it, right? Now these are ready. So now here in the Express app, let's try to remove all the commented code, right? So it's now pretty much clean. Let's try to use, like, because this is a kind of async function, right? So definitely we can directly initialize our broker here. So await, I'm going to be say initialize broker, right? Cool. So now see, one single line can handle everything. Cool. And definitely, so here why we are, maybe we can check it out, like if the initialize broker is failed, maybe then application has to be exit. That kind of like, you know, mechanism also we can add it right there, right here inside this initialize broker. But this is pretty cool right now. So we can just go ahead and start our application, and it'll start listening to our broker. Cool. Now I think that's all for this episode. In the next episode, what we're going to do, we're going to apply this similar kind of mechanism in our catalog service, so we can test it out, like, you know, our communication, and we can create some order in a real way. And then we're going to put our hands on the deployment part, so we can kickstart up our deployment strategy right there. Cool. All right, then thank you so much for your time, and I would like to see you in another episode. Bye bye.